Right now, the thermal slowdown between Super El Niño and the AMOC is making a complete mockery out of NASA's mathematical models, proving that nature laughs in the face of their simulations. If you're sick of the dogmas of armchair scientism and want to understand why climate oracles struggle to map out these shifts, you're in the right place. Unplug from the mainstream, turn on your brains, and stick around until the very end of this chapter. You know those beautiful 3D charts, glowing hellfire red like they came straight out of Dante's Inferno, showing the planet's climate fate from now until the year 2100? Those flawless simulations that claim to predict the exact year Europe turns into Siberia? Yeah, take that stuff, right-click, and send it straight to the trash. Today, we're breaking into the server room of global climatology to tear down modern scientism's favorite toy. And let's be clear, scientism is not science. Science is doubt, crashing code, failed experiments, and getting hit with a brutal reality check right in the face. Scientism is a whole different beast. It's the dogmatic claim that an algorithm running on a NASA computer has somehow become the ultimate crystal ball. Today, we're putting the two heavyweight titans of the ocean that are driving the media into a total frenzy in 2026 into the ring. Super El Niño in the Pacific and the AMOC, the Atlantic's conveyor belt. But we're going to do it using the language of people who chew on logic, programming, and a shred of common sense. No patronizing lectures, no guilt trips because you left the bathroom light on. Today we'll see why forcing these two phenomena into a marriage inside predictive software is the fastest way to short-circuit the most expensive supercomputers on Earth, and why climate orthodoxy, when it comes to the future, is groping in the dark exactly like we do when we're hunting for our house keys at midnight. To crush the mainstream narrative, we first need to understand who we're dealing with. You don't need a degree, you just need to think of Earth as a giant liquid cooling system, exactly like that custom gaming PC sitting on your desk. Let's start with the equatorial Pacific. That's where the first heavy hitter lives. El Niño. For university professors, it's part of the ENSO cycle, which stands for El Niño Southern Oscillation, but we like to keep things simple. So, imagine a humongous bathtub. Under normal conditions, they are incredibly powerful winds, the trade winds blowing from east to west. They do some heavy lifting. They push all the warm surface water toward Indonesia and Australia. Essentially, they pile up a literal hill of boiling water on one side of the ocean. On the other side, near Peru, cold, nutrient-rich water wells up from the deep to fill the gap. Everything runs smoothly. The ecosystem keeps spinning. Let's look at the actual 2026 outlook. The World Meteorological Organization and Copernicus indicate that sea surface temperatures in the Niño 3.4 monitoring zone are steadily climbing well past the plus 0.9 degrees Fahrenheit alert threshold, with predictive models indicating a high probability of jacking up past plus 3.6 degrees Fahrenheit by the winter peak. The media is already screaming Super El Niño, as if the record-breaking anomaly has completely unfolded. But they carefully omit a critical detail. The global ocean was already sitting on an insanely high thermal plateau before this cycle even kicked off. We are witnessing a structural lag in the system's thermal equilibrium, not some isolated fluke of the current month. But every now and then, nature's server experiences a massive lag. For reasons physics still cannot explain with absolute certainty, the trade winds lose their grip, slow down, or completely reverse direction. And what does that massive hill of warm water piled up in Australia do? It sloshes backward across the basin as a massive Kelvin wave, taking over the entire central and eastern Pacific. When this warm pool surges toward extreme anomalies, scientists sweat through their lab coats. All of that thermal energy shoots up into the atmosphere, warps the high-altitude jet streams, and completely overwrites the rainfall map across half the planet, a literal hack of the global weather system. Now, let's move over to the Atlantic and meet the second heavyweight, the AMOC. Behind this tech nerd acronym lies the Atlantic Meridional Overturning Circulation. This isn't a temporary glitch. It's Europe's permanent hydraulic heat pump. The mechanics are a masterpiece of basic middle school physics. Warm, salty water from the tropics travels along the surface toward northern Europe, The famous Gulf Stream is its forward deployed weapon. Once it gets close to Greenland, this water dumps its heat into the air, warming up our continent and preventing the UK from turning into a frozen Siberian wasteland. Once cooled, the water becomes incredibly dense and heavy, also thanks to the salt. And what does the heavy object do? It sinks. It plunges miles down into the abyss and heads back south along the ocean floor, restarting the cycle. One quick thing before we go deeper into this. If the way this planet actually works is your kind of story, subscribe and tap the bell so the next one finds you. The dynamics get interesting when we try to link these two phenomena in a chain of cause and effect. Triggering a strong El Niño acts as a massive thermal disruptor, altering deep convection over the tropics and shifting the trajectory of the global jet stream. This atmospheric chain reaction then reflects onto the Atlantic, where any chronic weakness of the AMOC drastically reduces heat transport toward high polar latitudes, trapping excess thermal energy right in the tropical and subtropical belts. The media narrative took these two systems, which are massive, non-linear, and chaos-driven, and crammed them into an apocalyptic meme. Global warming shoots Super El Niño to maximum capacity, while ice from Greenland melts, dumps fresh water into the Atlantic, strips out the salt, stops the sinking process, and crashes the AMOC. Result? Europe freezes over tomorrow morning. Beautiful, linear, and it sounds like the plot of a B-movie with an excellent special effects budget. But physical reality, guys, doesn't follow Hollywood scripts. Let's step into the engine room, the favorite part for anyone who knows what it means to write a line of code. What are those definitive warnings about the joint collapse of El Niño and AMOC that you read in the newspapers based on? They rely entirely on numerical models from the CIMP6 framework, the computing Bible of the IPCC. The media presents them to you as if they were infallible digital gods. But there is a massive structural bug that scientists know inside out, but carefully avoid talking about on talk shows. It's called parameterization. Let's explain this in plain English, using a comparison anyone who has ever played a video game will instantly get. Imagine Earth as a giant Minecraft map. No matter how powerful a supercomputer like the American Department of Energy's Frontier or NOAA's massive computer clusters are, monsters of power calculated in petaflops. They don't have enough physical memory to calculate the movement of every single molecule of air or water on Earth. It would be a computationally infinite operation. So what do programmers do? They partition the planet into a three-dimensional grid of blocks, exactly like Minecraft voxels. In standard cutting-edge climate simulations, each individual block of this virtual grid is humongous. We're talking about cubes that have a side ranging from 15 to 60 miles. Now run that programmer logic in your head. What happens to all the real physical phenomena that occur at a spatial scale smaller than a 60-mile block? Think about it. The formation of a single storm cloud, a 50-yard thermal ocean vortex, the marine turbulence caused by waves slamming against a cliffside, or the friction of wind over the ocean surface. The supercomputer, quite simply, does not see them. To the algorithm, that grid is completely smooth, digitized, and sampled at a very low resolution. It's like trying to render Leonardo da Vinci's Mona Lisa using a grid of 8 by 8 pixels. So, how do they bypass this bottleneck in the supercomputing centers? They cheat elegantly. They hard-code mathematical shortcuts into the system, empirical, approximate formulas based on old historical average, which are called parameterizations. Basically, they tell the software, look, since I can't calculate the actual physics of how a cloud forms inside this 60-mile cube, let's just establish a rule. When the virtual humidity of the cell hits value X, you just automatically plug in a value of Y for shade and solar reflectance. Do you see the catch? When researchers tried to tune these sub-grid processes to force short-term seasonal runs, like projecting how El Niño and the AMOC will interact over the next few months, even a minor 0.5% tweak to that estimated coefficient Y can cause the iterative simulation to spit out wildly divergent weather patterns down the line. This is where critics remind us of the core of chaos theory discovered by meteorologist Edward Lorenz in the early 1960s. Lorenz famously found that rounding an internal computer input from 6 decimal places to 3 completely flipped his short-term weather model. The butterfly effect was born. Now, climate models are designed to project long-term statistical trends based on energy boundary conditions, not to pinpoint exact seasonal weather. But the media commits to a massive category error. They take these highly sensitive short-term seasonal simulations, cross them with long-term climate models, and peddle the chaotic output as absolute, deterministic certainty for 2026. It's a commercial act of faith that misses the actual science. Want a historic example of how fragile these seasonal projections really are? Back in 2014, the world's top meteorological centers, including the hyper-tech European Center, issued a global alert. The monster of the century was coming, an El Niño so violent it would pulverize every historical record. Governments prepared. Commodity markets went wild. Do you know how it actually ended? In the real world, a series of localized storms in the Western Pacific, not predicted by the algorithm, abruptly re-engaged the trade winds. The warm anomaly deflated in a matter of weeks, and absolutely nothing happened that year. The real El Niño didn't show up until the following year, in 2015, completely catching the models off guard on a dead track. If computers can't actually predict what an ocean current will do 6 months out because of subgrid turbulence, how can we take their highly specific seasonal coupling simulations as gospel? If you want absolute proof that Earth laughs at the spreadsheets of climate scientists, we need to analyze a mind-blowing case study that the media buried under a massive wall of silence. Why? Because it completely destroys the narrative that humans are the only variable running the planetary system. The mystery of the Hunga Tonga volcano. In January 2022, an underwater volcano in the South Pacific exploded with primordial violence. Because it was a subaquatic eruption, the lava didn't create the typical massive cloud of ash and sulfur that blocks sunlight and cools the planet, like Mount Pinatubo did in 1991. Instead, the blast instantly vaporized billions of gallons of ocean water, shooting a historical volume of water vapor straight into the stratosphere. We're talking about an instantaneous 10% to 15% spike in the entire planetary stratospheric water vapor budget in a single afternoon. Now, if you are a true physics nerd, you know exactly what the most powerful, massive, and dominant greenhouse gas on our planet is. No, it's not the CO2 coming out of your car. It's water vapor. It drives nearly 50% of the natural greenhouse effect, which spikes up to 75% if you include clouds. It keeps Earth from being a frozen, unlivable ball of ice. The stratospheric injection from Hunga Tonga created a giant invisible thermal blanket at extreme altitude, trapping a massive amount of radiative heat. However, recent scientific consensus indicates that the net volcanic forcing from sulfate aerosols actually introduced a slight temporary surface cooling effect of around 0.09 degrees Fahrenheit, effectively offsetting the water vapor warming. And you know what the funniest, most profoundly ironic part of the whole situation is? Not a single CMIP6 mathematical model predicted or could have predicted the Hunga Tonga eruption. NASA supercomputers did not include unpredictable underwater geological activity in their code. Consequently, when this sudden, massive hydrological anomaly injected into the atmosphere completely sidetracked seasonal climate models, the algorithm suffered an analytical crash, struggling to account for this sudden planetary shockwave. When you hear media proclamations claiming the data from 2026 confirms our models, they are lying to you. The data is tracking the complex real-world aftermath of a geological event that their software doesn't even know how to properly calculate. Earth is an open, interconnected thermodynamic system, not a sterile laboratory isolated from the rest of geophysics. Let's toss aside the glitchy software and look at what exactly happens when El Niño and the AMOC cross paths in the real world, the one made of water molecules, not pixels. Here we enter the field of teleconnections, which is the elegant way oceanographers say that everything on Earth is connected to everything else via global atmospheric waves called Rossby waves. When El Niño fires up the Pacific, the massive heat released warps global air circulation, crosses the Americas, and dumps onto the Atlantic. Here, nature loves to defy the catastrophist with a total paradox. The altered winds change evaporation rates across the Atlantic, making the surface water significantly saltier. And guess what the AMOC needs to function? Heavy, salty water to sink. Paradoxically, the Pacific's warm anomaly ends up injecting fresh fuel into the Atlantic engine. It's a closed feedback loop, a system where cause becomes effect and vice versa. Trying to isolate a single variable to prophesy the permanent collapse of the AMOC is like kicking a broken TV set hoping it will stream Netflix. While paleoclimatological history proves that the AMOC can indeed experience rapid and major slowdowns, just look at the Younger Dryas or Heinrich events, the idea of a linear, irreversible collapse style the day after tomorrow is highly contested. Even the IPCC's own technical dossiers class a full AMOC shutdown within this century as highly unlikely. Earth's complexity completely runs over the simplified software of the climatologists, but alarm sells. Stability doesn't. At this point, a question naturally triggers from the deepest part of our logical code. If geophysical fluid dynamics are so inherently complex, fluctuating, and full of persistent questions, why does the public narrative often seem so monolithic? Why is it that if you raise a single nuance regarding the precision of these long-term models, you risk being framed as a complete anti-science heretic? The answer isn't strictly physical, it's sociological and economic. Welcome to the trap of modern scientism. In 1962, philosopher of science Thomas Kuhn wrote a foundational book, The Structure of Scientific Revolutions. Kuhn argued that the scientific community rarely advances through purely cynical, detached consensus. Instead, it establishes dominant paradigms. Once a framework becomes institutional orthodoxy, the surrounding infrastructure naturally works to defend it. Anyone introducing empirical data that complicates the core dogma isn't always answered with superior experiments. They are frequently sidelined, oversimplified, or left out of mainstream academic funding streams. In contemporary climatology, this structural inertia is heavily amplified by institutional funding mechanics. Let's run a real-life simulation. You are a young, untenured researcher at a European university. You need to secure your salary and keep your lab lights on. If you submit a research grant proposal titled Analysis of the Natural Cyclical Variations of Atlantic Currents over the last 2,000 years, do you know how much funding you might get? You're looking at a near zero probability. Review committees will tell you there is no immediate social urgency. But if you shift that exact focus to predictive modeling of an accelerated AMOC slowdown and its high-risk impacts on European agriculture by 2030, the institutional funding gates suddenly slide open. You don't need to invent cartoonish, shadowy conspiracies to explain this. It is a straightforward system of institutional and economic incentives. High-stakes climate alarm drives massive government appropriations, moves headlines, generates platform clicks, justifies expansive transnational regulatory frameworks, and cements academic tenures. Scientific caution, rigorous methodological doubt, and the candid admission that we currently lack the structural resolution to map this coupled system perfectly don't produce high-yield institutional capital. The more a system rewards the most dramatic, deterministic output, the more it creates a self-reinforcing algorithmic loop, one that institutional orthodoxy has very little financial incentive to disrupt. To wrap this up, guys, the takeaway message here isn't an invitation to indifference. It is a battle cry for logic, intelligence, and the authentic scientific method. Earth is not a fragile piece of glass ready to shatter at the first rounding error. The oceans are thermodynamic engines of unimaginable power, packed with an adaptive capacity and self-regulating mechanisms that our current models can't even map out. Super El Niño will make its presence felt through its natural cycles, shifting thermal energy and reshaping tropical rainfall just as it has done since the dawn of time. The AMOC will undergo its cyclical fluctuations, slowing down and speeding up along the natural tracks of the Atlantic multi-decadal oscillation. But the idea that the interaction between these two giants is an apocalyptic equation already solved and certified by the latest supercomputer is a massive cultural mystification that insults the intelligence of anyone who knows how real scientific research works. Don't let yourself be brainwashed by digital doomsday prophecies. Never lose your appetite for tearing down forced consensus, asking uncomfortable questions, digging into raw data, and demanding empirical proof instead of virtual simulations. Real science is not a dogmatic oracle you blindly obey with a bowed head and a guilty heart. Real science is a magnificent intellectual adventure built on doubt, verification, and the sacred freedom to think for yourself. Stay curious, stay skeptical, analyze the code of reality, and don't let the pixels fool you. Do you think current climate models are still actual scientific tools, or have they just become marketing software used by politicians to farm views? Go wild in the comments. And if the models can't even tell you what the ocean does 6 months out, wait until you see what the sky has already scheduled. Watch every rare cosmic event you'll see in your lifetime.